Welcome to my channel. Let us discuss some important problems on electrostatics, that is how to calculate the capacitance. Now here the problem is the dielectric. Here this is a parallel plate capacitor filled with a dielectric, and the dielectric constant varies according to the relation K equal to A plus B into X. A and B are constant, and the dielectric varies in a direction perpendicular to the plane of the plate. Separation between the two plates is D. Area of each plate is A. And here it is given that K2, that is the dielectric constant at the point X equal to D, is greater than the dielectric constant at the point X equal to 0. With this data, let us find out the capacitance of the capacitor. To start with, you impart a charge Q to the lower plate and calculate the potential difference between the two plates, and from that capacitance, that is the ratio between the charge on either plate to the potential difference, can be obtained. So let us start. Now intensity at any point near the plate equal to E charge Q by A, permittivity of the medium epsilon, that is equal to Q upon A. Epsilon 0 is epsilon 0, K as a function of X, that is Q by A epsilon 0 1 by KXA plus BX. Now this intensity E equal to minus dV by dx, or dV equal to minus E dx integral x varying from 0 to d, b varying from, that is here the potential is B, and that is maximum potential. The potential at the upper plate may be some value, but since you are considering the potential difference, let us assume it is 0. So it is equal to minus B. That is the potential difference between these two plates is minus B, equal to E equal to Q by A epsilon 0 integral 1 upon A plus Bx dx, x varying from 0 to d. Now this integration is equal to minus minus cancels, so B equal to Q by A epsilon 0, Q by A epsilon 0. This is ln of A plus Bx divided by B, and x is 0, x is the upper limit is d. Now, so the potential difference is equal to Q A epsilon 0 B logarithmic of ln of x, upper limit is d, that is A plus BD by x is 0 here, so by A, ln A plus BD minus ln of D, that is ln A plus BD by here A. Now this is equal to potential difference. Now we can find out the constants A and B in terms of the value K1, K2, because K, as you know, equal to A plus Bx. Putting x equal to 0, K equal to K1 it is given, so K1 equal to A, and putting x equal to D, K equal to K2, A equal to K1 plus B into D, so that the value of constant B equal to K2 minus K1 by D, so that the potential difference between the two plates is G equal to Q A epsilon 0. In place of B, it is K2 minus K1, D go to the numerator into logarithmic of ln of A plus BD, that is 1 B by A, K2 or BD equal to K2 minus K1, BD equal to K2 minus K1 by A equal to K1. As a result, the potential difference between the two plates is Q D A epsilon 0 K2 minus K1. K1 on simplification, K1 got cancelled, so log of K2, K1 plus K1 minus K1 got cancelled, so it is log of K2 by K1. So that the capacitance equal to C equal to Q by B, that is Q by B or A epsilon 0 K2 minus K1 by Q by B, A epsilon 0 K2 minus K1 D ln of K2 by K1. Now the capacitance for the given parallel plate capacitor is equal to A epsilon 0 K2 minus K1 by D separation between the two plates ln of K2 by K1. Now can we put K1 equal to K2? If K1 equal to K2, then this becomes 0 by 0 from this is down 1 0 this is 0. But because of assumption that we have taken K2 and K1 are two different values, because dielectric constant varies perpendicular to the plane of the plate, we cannot put here K2 equal to K1 because it will contradict our assumption. So the result is A epsilon 0 K2 minus K1 by separation D ln of K2 by K1. Now the second question is a little bit different, but it is also to find out the capacitance. Here it is given a square plate. The parallel plate capacitor has two plates of square shape and each edge of length A, that is area is equal to A square. But it was here the dielectric constant varies perpendicularly in the direction of X shown, but here the dielectric constant varies along the edge of the plates, so that according to the relation K equal to K0 plus alpha X, alpha is a constant, K0 is a constant. K0 is X, when X equal to 0, then the dielectric constant equal to K0. So let us find out the expression for capacitance here. Now to obtain an expression, you choose an elemental length at a distance x. This is x equal to 0. This elemental length, imagine the parallel plate and x equal 0. You at a distance x, you choose an elemental strip. This is of area. The elemental length be dx, and this is of A. So this area is, so this is A dx, and below A dx, this is parallel plate, elemental length of the parallel plate. So two parallel plates of area ADX separated by a dielectric medium having dielectric constant here equal to K0 plus alpha x. Now the elemental capacitance here is DC equal to epsilon area by D. What is A here? Because when I write DC elemental capacitance, I should write area. Area of that elemental capacitance is equal to A's length A into dx area. And instead of epsilon, I can write permittivity epsilon 0 A dx into the dielectric constant, that is K0 plus alpha x by D. Now then you can choose the integration to find out the capacitance of the capacitor, that is integral dc is c, then epsilon 0a upon d taken from x varying from 0 to a is the length of the edge, so epsilon 0a by d k0 alpha x dx. As a result, the capacitance value equal to epsilon 0 a by d k0 dx, k0 dx integral x, and this is a. Now this is alpha x dx first integration x square by 2 and putting the value is a square by 2. So the capacitance of the capacitor is taking a common epsilon 0 a square by d, and it is k0 alpha a by 2. This is the value of capacitance. If you write A equal to area of the plate, then separation, we have K0 dielectric constant plus alpha A by 2. So this is the expression. Now the two problems are of same nature, but the dielectric constant varies perpendicular to the edge. The method that we applied here for second case cannot be used for the first, because you cannot imagine. If you imagine plates in between the dielectric constant, then the things would have been different. So this is solved by differential integral method, and this is solved by imparting a charge q and finding out intensity of electric field using Gauss law, and then potential difference, and then capacitance. These are two important questions, very conceptual, and the physical basis can help the students appearing Neet examination as well as JEE-MAIN examination or advanced examination. Thank you.